So in this clip, we'll do an example using Fubini's theorem, and we'll see that even though we get the same answer either way, the difficulty level is quite different doing it in one order versus the other. And so the example that we're going to look at is the function y times sine of xy, and we'll be doing it over this rectangle right here. And I guess I should probably point out that this is a good example of a situation where the function that you're looking at is not factorable as a product of x times a product of y. So if you're wondering like, hey, when does that not happen? Here's an example, because you can see that the x and y are inextricably bound up together inside the sine function, so you can't split those apart. So okay, getting down to brass tacks, let's see. So we'll go from 1 to 2 times the integral, and then the integral from 0 to pi of y sine x y dy dx. And so let's see. So now in order to do this, we are going to need to use integration by parts. So in this class, we won't typically have to use a lot of like crazy formulas like you did back in Calc 2, but integration by parts and u substitution, or change of variables that is, are totally fair game. So let's see. So if we take u to be y, then du is going to be dy, and if we take dv to be sine xy, then our v is going to be minus 1 over x cosine of xy. So this integral becomes the integral from 1 to 2 of, and then we have minus y over x cosine xy evaluated from 0 to pi, plus the integral from 0 to pi 1 over x cosine xy, and that's dy, and that whole business is then integrated with respect to x. Okay, so that's the integral from 1 to 2 of, and then let's evaluate this thing from pi to 0. So we get minus pi over x cosine pi x, minus 1 over x squared sine of xy evaluated from 0 to pi dx, and that simplifies to the integral from 0 to 1. Then we still have the same business for the first part, but now we can evaluate this guy from pi to 0, and we have 1 over x squared sine pi x. Okay, so now we can go and integrate this one, and again we're going to need to use integration by parts. And so here, let's see, so u is 1 over x, and then du is minus 1 over x squared dx. Our dv will be the other part, which is minus pi cosine pi x. So v is sine of pi x. Okay, so let's see, putting that to work. Our first part, we get the boundary term 1 over x sine pi x evaluated from 1 to 2, and then we have the integral from 1 to 2 of 1 over x squared sine pi x dx, and then we have minus, look at that, the same thing, 1 over x squared sine pi x dx, and then we can cancel these guys, and we just have to evaluate that last guy there, and so then this is going to be minus sine 2 pi over 2 plus sine of 1 pi over 1, but when you know it, sine of an integer multiple of a pi is 0, So we get a solution of 0, which is neither here nor there. No need to read into it in any particular way. It doesn't signify anything. But if we had done this in the other order, so that we're doing the dx one first, then what we see is, let's see, so now I can use that y that's out in front as the du for my change of variables, putting u equal to xy, and so this becomes the integral from 0 to pi of minus cosine xy evaluated from 1 to 2 dy, and integral from 0 to pi, so that's cosine y minus cosine 2y. And so then doing that integral, we get sine of y minus 1/2 sine of 2y from 0 to pi. And then for the same reasons as before, we see that that gives us 0. All right, so much less work. So the moral of the story is, think carefully about which way you want to try and do it. We'll see examples of integrals that are difficult or in fact impossible to solve one way, but what might be readily solvable if you set them up in a different order. And that's really kind of the heart and soul of like what you learn in a class on multivariable integration, is kind of how to set up the integral in the first place, and then how to think about how to evaluate it and what order to do it in a way that doesn't like destroy your will to live. Oh, and I forgot to mention, this is typically the place in the course where students ask me, hey, so how do I know which order to set it up in? And the answer is, unfortunately, experience, and a lot of staring. So it turns out it's really an ad hoc thing. There's no like 3-step procedure for this is what you do to figure out which order is going to be easier to do it in. You just kind of have to examine it and think about it and look like, oh, does this look nasty? If it looks nasty, maybe I'll try it the other way. But yeah, there really is no like set rule for here's how you tell.